All right, so we're still in section 1. We're still talking about 3D coordinates. We're going to be in three-dimensional space for the rest of the week, okay? And that's what your test is going to be over Tuesday or Wednesday, depending on the class period, since you guys your first hour would be Wednesday, okay? So the first thing we're going to talk about is finding the midpoint. Yesterday we talked about distance. Distance and midpoint kind of get grouped together when you're talking about geometry. So does anybody remember if we have two xy coordinates, how do we find it? How do we find the midpoint?
X plus X over 2, comma Y plus Y over 2.
Okay, we have to find the average of the x's, the average of the y's. So in 3 dimensions, we're going to have to do that with all of them. Okay, we're just going to also find the average of the z's. To find the middle, we want to find the average. Okay, so here are the 2 points we are going to find the midpoints between. Okay, so our midpoints will be the average of our x's, the average of our y's, and the average of our z's. What's our midpoint? -1, 0, 7.5, or 15.5. And that is it. The next thing I would like to talk about are spheres. Okay, spheres in 3 space are going to be similar to what in 2 dimensions? Circles, okay? So let's recall, what is the standard form equation for a circle? Remember? Okay, not in polar form. You guys are thinking r equals something, right? In polar form, that would be excellent. We're going to stick in rectangular form. Equals, nope, r squared. When we write ellipses in standard form, we would have those A's and B's as denominators and equals 1. I think that's what some of you were thinking of. We sometimes wrote our circles like that, but this technically is the standard form of a circle. Okay, you remember this from geometry a little bit? Okay, yes, you saw this in geometry. Okay, so a sphere in 3 space is going to have a standard form that looks like this. Okay, our center is now HKJ. We still have a radius for our sphere, R, And so it looks very similar. We've just thrown in the z minus j, the quantity squared. Okay. So we are going to write the equation of a sphere with the center at 2, negative 4, 3, and a radius of 3. Okay. So if our center is at 2, negative 4, 3, then we are going to write x minus 2, the quantity squared, plus, whoops, I don't know why I said y plus 4, the quantity squared, plus z minus 3, the quantity squared, equals 9. Our radius is 3, so r squared is 9. Okay. Now, you will be asked to write the equation of a sphere given different information. Here I gave you the center and the radius. Okay? If you were given the diameter, what would you have to do? Divide it by 2. Okay? Now, it is possible that I could give you the end points of a diameter of the sphere. If I gave you the end points of a diameter of a sphere, what would be your strategy? Okay, you would have to use the midpoint, and that would give you your what? Okay, and how would you determine the radius? Okay, then you could use the distance formula to find your radius. Okay, you can either find the distance from diameter to diameter or diameter endpoint to endpoint and cut it in half. Or if you find your center first, you can find the distance from your center to an endpoint for your radius. Okay, you will have a couple of those problems in your homework, so I just kind of wanted to talk it through before you got there. Okay. Now, the last thing we're going to have to do, okay, get excited. No. I'm going to give you an equation, and you're going to need to put it into standard form, which means we're going to have to complete the square how many times? 3. Okay, so what did I always suggest doing before completing the square? Group everything together. So I'm going to group x squared and negative 2x together and leave room for our mystery number. I'm going to group y squared and 4y together and leave room for our mystery number. Z squared minus 6z with our mystery number. Where do we want the plus 8? Okay, we want to subtract the 8 to the other side, and we'll have to add our mystery numbers there too. Now the nice thing about this problem is that all of our coefficients for our squared terms were 1, right? So that saves us some work, right? Silver linings here. Okay, so what completes the square? 1, so we add 1 to both sides. What completes the square here? 4, so we'll add 4 to both sides. What completes the square here? So we'll add 9 here. So we have, this factors to what? X minus 1, the quantity squared, plus y plus 2, the quantity squared, plus z minus 3, the quantity squared, equals this. Okay? So we have it in standard form. Now we can determine what is the center and radius. So where is our center? One, negative 2, 3. And our radius would be the square root of 6. Okay. You have 30 minutes. No, you don't. You have like 25 minutes left in class. Oh, no, I did forget about this. Okay, this is, put your pencils down. I want to take a few minutes just to show you some three-dimensional figures. Okay, you guys can imagine what a sphere looks like, right? A sphere is like a ball, right? Okay, so if we take our conics and throw them into 3 dimensions, we can make some really cool things. So this is an ellipsoid. Okay, it's basically a 3-dimensional ellipse. Okay, what does it look like? A blimp, an egg, a rugby ball. What happens is if we wanted to graph this, we would find traces. So we would look at what the ellipse would be in the XY plane, in the XZ plane, and the YZ plane, and then we could create that picture. Okay, we're not going to. Okay, I just want to show you these things because I think they're cool. All right. The next thing, this is called a paraboloid. This is an elliptic paraboloid, where basically we have a bunch of ellipses that make parabolas, right? Looks like a cup, right? Okay. This is a hyperbolic paraboloid, so it's basically a bunch of parabolas that form a hyperbola. Okay, what does it look like? A great ball, right? I just think it's a... All right. These are hyperboloids. Okay. So these are hyperbolas with the help of a couple of ellipses. But we can either make this one, it's just one sheet that's formed together. This one is 2 sheets where you have 2 separate pieces. Okay? We are not going to graph these, but these are things that we can make in 3 dimensions with our conic sections. Alright, just wanted to show you so that you could see them. Alright, all I really care about are the figures though. Okay, so this is your homework. If you did not finish last night's homework, you have time to work on that and these problems. Okay, if you have last night's already finished, you should be able to get this done before you leave class.